Only 1/3 remains. That's the average taurine concentration in the blood of people over 60 compared to 5-year-old children. Such a drastic loss of an endogenous substance must surely have far-reaching consequences for our aging process.
This age-related decline in taurine actually sheds new light on a substance that long remained in the background. Taurine itself is a fascinating organic acid, a sulfonic amino acid to be precise. Unlike the classical amino acids that build our proteins, taurine is not integrated into those structures. Nevertheless, we find it in remarkable concentrations in almost every cell of our body, especially in the heart, brain, and muscles. As early as the 1970s, the fundamental importance of taurine became clear when it was observed that cats, which can hardly produce it themselves, suffered from severe problems such as blindness and heart failure due to a deficiency.
It is indeed remarkable when a substance that is so essential for some animals, and which we only casually associate with energy drinks, is suddenly discussed as a possible key to understanding aging. This clear decline with age makes one sit up and take notice. One thinks of the typical accompanying phenomena of aging: decreasing bone density, reduced muscle strength, possibly mood swings, and a slower metabolism. It naturally raises the question of whether there might be a connection.
And that very connection comes into focus. Taurine is involved in an astonishing number of fundamental processes. It is essential for calcium regulation in our cells, which in turn is crucial for the function of our mitochondria, the cellular powerhouses. As an osmoregulator, it supports the transport of sodium and potassium across cell membranes, which stabilizes muscle contraction and heart function. Particularly noteworthy is its role as a potent antioxidant that protects our cells from oxidative stress and can mitigate inflammatory processes. A decline in these diverse protective and regulatory functions due to decreasing taurine levels in old age could indeed impair cell health and organ function.
That makes things more understandable. When a single substance influences so many control mechanisms, its absence is definitely noticeable. Nevertheless, the recent headlines about animal studies suggesting that taurine can extend lifespan sound almost revolutionary. As a layperson, one is quick to be skeptical, especially when it comes to the complex topic of aging. How robust are such results from the lab when it comes to us humans?
The skepticism regarding the direct transferability of animal studies is absolutely justified and an important pillar of scientific integrity. However, the results, particularly from the comprehensive study published in 2023 in the renowned journal Science, are very compelling for the animal models examined. In nematodes, taurine led to a dose-dependent extension of lifespan. Mice that received taurine daily not only lived 10 to 12% longer, but also showed improved bone mass, increased muscle endurance, reduced signs of anxiety and depression, better insulin sensitivity, and an overall more vital immune system. Even in rhesus monkeys, comparable positive effects were observed. The evidence for this species, therefore, is strong.
These are undoubtedly impressive results in animals, but humans are neither mice nor monkeys. The big question remains whether similar effects could occur in us. Are there any indications outside of these animal experiments signaling a similar trend? After all, one is looking for something tangible for everyday life.
A direct look at humans is therefore the next logical and decisive step. This is where observational studies come into play. An extensive analysis of data from almost 12,000 European adults from the EPIC-Norfolk study revealed interesting correlations. People with higher blood taurine levels tended to have a lower risk of type 2 diabetes, struggled less with obesity, and showed lower blood pressure values. Although this does not prove a direct cause and effect relationship, it might also be that a healthier lifestyle leads to higher taurine levels. These associations are striking and match well with the results from the animal studies.
These correlations are an important piece of the puzzle, but they still leave room for interpretation. Naturally, one wonders what would be necessary to gain real certainty in this area, and how does our own lifestyle fit into the picture? For example, exercise is often touted as a fountain of youth. Could physical activity have something to do with our taurine levels too?
To clarify the question of causality in humans, randomized, placebo-controlled, and double-blind clinical intervention studies are needed. Fortunately, such studies have already been initiated. Notably, the TauAge study, being conducted in Germany at the Technical University of Munich, is of particular interest. In this study, healthy men and women aged 55 to 75 receive either a daily dose of 4 grams of taurine or a placebo over a period of 6 months. The innovative approach here is that the focus is not primarily on specific diseases, but on determining the biological age of the participants using modern methods such as epigenetic clocks and plasma protein analysis. This is the scientific gold standard.
The ability to measure biological age so precisely naturally opens up entirely new perspectives in aging research. This makes the potential outcomes more tangible. 4 grams of taurine daily might seem like a relatively high dose at first glance. Is such a dosage considered completely safe? And while we await the results of these elaborate studies, are there perhaps aspects we can already consider in daily life to potentially benefit from its advantages?
The question of safety is absolutely central to such interventions. The European Food Safety Authority, EFSA, has defined an observed safe level for taurine of up to 6 grams per day for humans. The dose used in the TauAge study is therefore within this safely established framework. Regarding immediate practical implications, the mention of exercise is very apt. There are indeed studies that suggest physical activity can increase the concentration of taurine in the blood. This might be one of the many mechanisms through which exercise exerts its health-promoting effects. A balanced diet that includes natural taurine sources such as seafood, fish, and meat is also a good approach, while science continues to uncover further insights.
It is truly an exciting phase in aging research, where a seemingly simple endogenous substance like taurine provides such promising avenues. The possibility of extending the years of healthy living, and not just lifespan, is a tremendously powerful incentive. It reinforces the notion that we are not passively at the mercy of the aging process.
Exactly. That is the encouraging perspective. The complexity of our body and its molecular mechanisms is endlessly fascinating. The current research on taurine is promising, and ongoing human studies will hopefully soon provide even more precise answers. Until then, it underscores the importance of a healthy lifestyle, which includes regular exercise and a conscious diet, as a fundamental contribution to vitality and well-being at every stage of life. Aging research is entering exciting times, and taurine could prove to be a valuable factor.
We would like to sincerely thank you for spending this episode with us. Your support and interest mean a lot. We hope you were able to gain exciting insights and valuable food for thought. Stay curious, informed, and inspired. Together, we are shaping a better future. As always, we wish everyone a long, healthy, and happy life. Until next time.